Hello everyone, this is Peter from Learnwithuncletee, and in this tutorial we're going to be discussing integration by parts, which is still continuous learning for our introduction to calculus for beginners. Okay, so now firstly, one of the first things that you need to know about integration by parts is that it is a synonym of the product rule that we have in differentiation. So it means it's from differentiation that is from product rule in differentiation that we are going to derive the formula that we use for integration by parts. Now, basically, what it's actually doing is that if you are differentiating, for example, let's say that you have a function y is equal to u times v. If you are to differentiate this, let's assume you use the first principle to differentiate this, you arrive at the y dx to give you u dv dx plus v du dx. And this formula is what you refer to as product rule. So in differential calculus, if you are differentiating the product of two functions, you can directly apply this formula to get your the y dx. So also when we are integrating the product of two functions, we also need the formula for integration by parts to actually solve this. So we are going to start from the product rule formula, then we are going to integrate both sides to see what is going to get us. So now let's start from this product rule formula, which states that the y over dx is equivalent to u dv over dx plus v du over dx. Now, if I decide to multiply through by dx, this will give us the y over dx multiplied by dx is equal to u dv over dx multiplied by dx plus v du over dx multiplied by dx. So here dx will cancel dx, we'll be left with the y here is equal to u dv plus v du. Now, if I integrate both sides, integral dy is going to give us integral u dv plus integral v du. Now, we know that integration is our antiderivative. That is, if you have y, if you differentiate y, you get the y. If you integrate what you differentiated, you are supposed to get back what you differentiated. So it means when you integrate the y, you are going to get y. If you integrate the u, you are going to get what? You are going to get u. If you integrate the v, you are going to get v. So if you integrate the anything, you get that thing. So integral the y, this will give us y is equal to integral u dv plus integral v du. So now, since we have derived that y is equal to integral u dv plus integral v du, y from product rule, what gave us the y dx to be u dv dx plus v du dx is when our y is equal to u times v, which means our y is equal to what? uv. So what it means here is that this y is the same thing as uv, that is u times v, is equal to integral u dv plus integral v du. So you can decide to make either integral u dv the subject of formula, or you make integral v du the subject of formula. So basically, most times, most textbooks use integral u dv as the subject of formula. So what it means is that integral u dv will then give us uv minus integral v du. So, and this formula is referred to as the formula which we refer to as integration by parts. Integration by parts. So the parts here, u and v. So u is a function, dv is a function. So now let's apply it in the question to understand what we are doing properly. So we are going to take 3 questions to properly evaluate these. So for example 1, we have to evaluate integral x times e raised to power x dx. So, of course, our formula is integral u dv is equal to uv minus integral v du. So, in this formula, we have integral u dv giving us this. So, it means in the formula we need u, we need v, and we also need du. So, if I compare what we have at the left hand side with what we have in our question here, that is, if I say that integral x e raised to power x dx is equal to integral u dv, it means that if integral this is equal to integral this, what you are trying to integrate can be equal to each other. We can take our u to be x, or we can take our u to be e raised by x. So if we take u to be x, it means dv will be e raised by x. But if we take u to be e raised power x, it means dv will be x. Now, why you can interchange this is because u is multiplying dv. We know that multiplication in mathematics is commutative. 1 times 2 is the same thing as 2 times 1. So it means that we can say that let u to be equal to x and dv to be equal to e raised by x. So if u is equal to x, in the formula we need du. Let's find du. We can find du from here by differentiating u. So if we differentiate u with respect to x, here, if we differentiate x, you're going to get 1. So it means that du is the same thing as what? Dx. So since du is equal to dx, now we took that let u to be equal to x and dv to be e raised by x. In the formula, we need v, we don't need dv. So for us, since we have dv and we're looking for v, it means we integrate the v. So it means that integral the v will give us integral e raised by x. If integral the v is equal to integral e raised by x, integral the v is going to give us v is equal to, if you integrate e raised by x, you're still going to get e raised by x plus an arbitrary constant c. So here now, integral u dv, which is now integral u the v, which is now integral x e raised to power x dx, will now be equal to uv. So our u is what? X multiplied by v e raised to power x minus integral v du. Our v is e raised to power x multiplied by du. Du is now equal to what? Dx. So this will be dx. So what it means here is that integral x e raised to power x dx will give us x times e raised by x e raised by x, minus, if you integrate e raised by x, you still get e raised by x, plus an arbitrary constant c. So integral x e raised by x dx will give us, if you factorize e raised by x out here, you have e raised by x into x minus 1 plus an arbitrary constant c. So, and that will be the answer to that question. So now let's take a second example now. Example 2. We have to find integral, or let's say we have to evaluate integral x times sine x dx. So the same approach, we can take our u to be x. If our u is equal to x, then it means our dv will be equal to sine x. So we need du dx is going to give us 1. So here we integrate the v to get our v. So integral the v will give us integral sine x. If you integrate the v, you're going to get v. If you integrate sine x, you're going to get minus cos x. So it means integral x sine x dx will give us uv minus integral v du. So integral x sine x dx will give us our u, that is x, multiplied by our v minus cos x minus integral v minus cos x du. And our du from here, if we cross multiply, du will give us 1 times dx. So it means du is equal to dx. So this will be minus cos x dx. So what it means is that integral x sine x dx will give us minus x cos x. We can factorize this minus out. So this will be plus, if we integrate cos, you're going to get sine. So that will be sine x plus an arbitrary constant c. So what it therefore means is that integral x sine x dx is equivalent to sine x minus x cos x plus an arbitrary constant c. And that is going to be the final answer to that question. So let's take example 3 now to solidify our understanding on integration by parts. Example 3, we are to evaluate integral x squared cos x dx. So same approach, we'll take let u to be equal to x raised to power 2 and dv to be equal to cos x. So if u is equal to x raised to power 2, du dx is going to give us 2x. So integral dv will give us integral cos x. So from here, it means that du is equal to 2x dx. Integral dv will give us v. If you integrate cos, you are going to get sine x. So it means that integral x squared cos x dx will give us our u, that's what? X squared multiplied by v sine x minus integral v du. So that will be sine x. And our du, that's 2x dx. Okay, so that will give us sine x times 2x dx. So integral x squared cos x dx will give us x squared sine x minus, now we can factorize these two out. So we can say minus 2 integral x sine x dx. Okay, so now for x sine x, we still have to use a mini integration by part to solve these second parts. So let's say integral x sine x dx. If we take u to be equal to x and we take the v to be equal to sine x, so if we differentiate both sides, the u dx here is going to give us 1. So integral dv will give us integral sine x. So from here, it means du is equal to dx. Here, v will give us minus cos x plus arbitrary constant c. So integral x sine x will give us uv, that's x times minus cos x, minus integral v minus cos x times du dx. So integral x sine x will give us minus x cos x plus, if we integrate cos, I brought out this minus times minus, that's why I'm writing plus. So it's remaining cos x dx here. If you integrate cos x, you're going to get sine x plus an arbitrary constant c. So integral x sine x dx will give us x cos x, or let me just say sine x minus x cos x plus c. So what it means here is that integral x squared cos x dx will give us x squared sine x minus 2 multiplied by sine x minus x cos x Now I can close the brackets because if 2 multiplies a constant, it will still give you another constant. So we'll just write plus c. So here integral x squared cos x dx will give us x squared sine x minus 2 sine x plus 2x cos x plus c. So basically the final answer should be x squared cos x. You can still try solving this further. Integral x squared cos x dx will give us, we can factorize sine x out here. So we are going to have x squared minus 2 sine x plus 2x cos x plus an arbitrary constant c. So the final answer is x squared sine x minus 2x cos x minus 2x cos x plus an arbitrary constant c. Okay, and so that's the final answer. So for this tutorial, this is where we're going to bring it to an end. If you have a question, you can drop it in the comment section. If you have not subscribed to our channel, you can easily subscribe by clicking the subscribe button. It is going to help this video to reach more and more students. So thank you very much. See you in the next tutorial. Once again, this is Peter from Learn with Uncle T.